In last session, we discussed about what database is, why we need a database, what is a DB, what is DBMS, what is RDBMS, what's the difference between them, and we also saw installation of MySQL, and we saw like two uh, clients for the MySQL, GUI client and CLI client. So GUI client is called as a workbench, and and we also saw command line interface. We also saw like how to connect to the MySQL database server from these two clients. So any to connect to any database server, we can actually connect it in two ways. So using like two clients, two type of clients. One is GUI client, other is CLI client. And for connecting MySQL also, we have like workbench and command line interface. And in the last session, we saw how to connect from both of these CLI and GUI. We saw how to connect to the MySQL server. In this session, we'll discuss about SQL commands. So we also learned that to communicate with the database server, we need a language. That language is called as SQL, Structured Query Language. And using only this language, we can communicate with the database server. And from where do we communicate is, we actually communicate to the database server from client. We also saw workbench, right, in the last session. So let me launch my MySQL workbench. So just press Windows key on your machine and type workbench. You'll see here MySQL workbench. Just click on it. So you'll see a screen like this. We need to create a connection to our database server. We already did that in the last session. If you observe, you can see here the connection got saved here. Even if you don't have the connection also, no worries. You can just click on this plus symbol, and then you can create a new connection here, providing some name here. Then host name, we need host name and port number, then credentials, username and password to connect to the database server. And then if we click on this OK, this is how we will see a connection here. And I already have the connection, so I just need to click on this. It will prompt to provide the password. I will just provide my password. Then you can see here, like you can see here, I am connected to my database server. And by default, you will not see anything here. Like we need an editor to actually issue the SQL commands to the database server. But we don't see any editor here. To get the editor, you just need to click on File and then click on New Query tab, or you can just click on this icon bar, first one. Just click on that so that we'll get a editor here. This is called as SQL editor. From here, we will actually write the SQL commands and communicate with the MySQL database server. This is what we call it as MySQL workbench, and this is GUI client. And we also discussed that there is a, if you see, there is a database here, and database and schema are same in MySQL is also what we discussed. And you can see there is a schema here, classic models, and it has some tables in it. So this is the schema database which we will be using for all the to actually understand the SQL sessions. And there is some test DB here. Let me drop it. We'll create it anyway. And whatever SQL command we write here, say for example, let me, all these are the schemas which I created except this SYS, sys schema, which comes with by default with the installation of MySQL database server. So let me show you how we can actually write a small query and get the result from the database server. So you can just see here, DemoDB is one of my schemas. I'll just click on this so that it gets expanded. and you can see tables here listed. Click on these tables. You can see tables here. Click on one of the tables, employee table, and right click, select rows. So if I do this, there will be some query. You can see some query here. With that, we call each SQL command as query. So from now onwards, when I say query, it is just an SQL command, and this command goes and like as a request, it hits the database server, and database server responds with the result set. You can see here employee is one of the table, and what's the table we discussed. Like table is a combination of rows and columns. Rows are read from top to bottom. You can see here 101 Smith manager. All this entire thing is information of one employee here, and that is called as one row. And what is column is a piece of information is a column. Like if you within this row, if you take only e name, employee name, then that is a column. EID, employee ID is one column, designation is one column. Like this, a table can have n number of columns and n number of rows. This is what we call it as a table. And this table is already there on the in my DemoDB database or schema, and within the schema we have tables. So a schema just groups the tables, and within my DemoDB I have two tables. So when I wanted to query, when I wanted to retrieve the record from my employee table, I will just issue this command. Then I'll get the result set like this. This we call it as result set. Now let us actually understand SQL commands in detail. So we already discussed SQL is a language used to communicate with the database server. So from as a client, we actually choose either GUI client or CLI client to communicate with the database server. And any client you choose, we definitely need to issue some SQL commands, as database server can only understand SQL, structured query language. So we now we need to learn SQL language definitely, as we wanted to learn SQL commands. So you can see here these are the different under SQL language. These are the different sub languages again. So SQL is again categorized into is again divided into different categories. We can see here data definition language, which is used to. So these are a group of commands which are used to actually perform some definition, like creating a table, altering a table, or completely removing the table, that we call it as drop. All these comes under the definition. So whenever we are working on the structure of the mainly structure of the object, so to defining the structure of the object, all whatever commands we use to actually define and define the structure of the objects, that all comes under the data definition language. And DML is data manipulation language. So we have a table now, fine, created a table. We wanted to add some data into the table, or in the later point of time we wanted to modify some data in the table, or we wanted to delete some rows into that from the table. All these comes under all these type of commands comes under data manipulation language, DML commands. Then DRL, or we also call it as DQL, so data retrieval language or data query language. So here we will not be performing anything on the data, but we actually we don't modify the data, but we read the data. We have some data stored in a table on the database server. We wanted to read the data. So for that, we use command called select. We use a command SQL command called select. With that, we actually read the data from the database server. We issue that command, and with that, and that goes as a request to the database, and database responds with a result set. So that type of commands we call it as data retrieval language or data query language. Next is transaction control language. where we actually control the transactions using commit, rollback, these type of commands. So why we need this is to control the transactions. So to control some incomplete transactions, or once to confirm the transaction, we use these type of commands. Next, DCL. DCL is about data control language. It's all about permissions. So providing the required privileges to the particular user on a particular objects is all comes under the data control language. This is how SQL is divided into different categories. Now we'll learn each of them in detail. You can see here. First one, DDL, data definition language. So here we actually define the structure of the object, how my object should be. Everything in database is called an object. It can be a database, it can be a table, it can be a view, everything. So synonym, it can be column, everything we call it as object. And you can see here uh, data definition language. These are all the SQL commands. These are the group of commands. So we use create command. Create is used to create like objects. Then alter. Alter whenever we define some structure using create, but in the later point of time, we wanted to modify the structure of the maybe table or a column within a table. Then we can use this alter command. Drop. Drop is used to completely remove the one or more objects from a table, or we can even drop the entire table, or we can remove the entire database schema itself from the database. So that is what drop is used for. And then truncate. Truncate is used to remove the rows from the table. We'll then rename. Rename is used to if you wanted to rename a column or a table, so we can use rename. All these are group of commands which comes under data definition language. Next comes DML. So as stated earlier, DML is data manipulation language. Once we have created a structure in the table structure, then we wanted to add some data into the table. That we can do using insert command. Then update. In the later point of time, if you wanted to update some data in the table, we already have the data in the table, but we wanted to modify some of the data in the table. Then we will use the update command. Then delete command. So in case like if you wanted to remove some information from the table, we can actually use the delete command. This group of commands comes under data manipulation language. And DRL, so data retrieval language or data query language, we use these commands to read the data from the database. We will not perform any operation on the data, but we will just read the data which is already persisted on the database. And that we use, and for that we use a command called select. Next, transaction control language, where we use command like commit, rollback, save point. So we wanted to commit some transaction. Commit is like permanently persisting the transaction or data onto the database. Rollback is like we are performing some set of commands. We are running some set of commands, but those are completely not done. So because of some interruption, in that case, we wanted to roll back all the commands which we executed till now. So in that case, we can actually use the rollback command. Save point is something like um, you know one point where we wanted to uh, roll back to our transaction or take the system to that point. So we can have some save points where we wanted the system to be taken to that point, so that we feel that from that point the system is healthy. So that's how we can use the save point. These are all the group of commands which comes under transaction control language. Next, DCL, data control language. So these are the commands used to mainly granting the privileges, and in after a particular period of time we wanted to revoke the privileges from a user on a particular object, then we can use these type of commands called data control language. So mainly it deals with the privileges for a particular user on a particular objects. These type of commands comes under data control language, and these are the two commands, grant and revoke are the commands which falls under data control language. Now we are going to see all of these, like we'll pick up first like DML, and then we'll learn what are all the DML commands and how we can write a query using these commands, the syntax of it, and in how many different ways we can actually write the queries, that we'll see. So we'll start with DML now. Then once we are done with that, then we'll see DDL. But in order to start DML, anyway, it again depends on DDL. So without creating the objects, we can't actually modify or add the data into the tables, right? So for that, we'll first start with some first DDL command called create. So you can see here, to work on anything, we first need a table. So database itself is like the data is stored in database in the form of tables. And again, these tables are grouped into some schemas. So first we need to have a schema created on a database. Only then you can actually use that schema and create tables inside that schema. And remember, in MySQL, we can either call it a schema as a schema or a database. So whenever we say database or schema, both are same in MySQL. And let's actually start creating a new database or a schema. So you are already connected to the database server now. This is my editor. How did I get this? When we connect to the database server, after connecting, we need to open the SQL editor. Once we open this SQL editor using this first icon bar, then we can actually start writing the queries. And the first thing we need to do is we wanted to create a schema first. Inside it, we wanted to create the tables, right? So this is what I'll do. Create database. I wanted to create a database or a schema, and I wanted to name it as testdb. So this is the syntax of it, or this is the command. Create database. So you can see what are all in blue color are like called as keywords particular to that database. And testdb is what we are providing. So you can provide any data here, any sequence of characters, we can provide it as the database name. Here I am providing it as testdb. And you can see here, it is actually terminated with a semicolon. Each statement in an SQL language is terminated with a semicolon. So it's not actually mandatory, but when you wanted to execute like group of statements, say for example, if you wanted to execute some 3-4 SQL commands is all together, then how to differentiate the 3 or 4 statements, like these are the 3 or 4 statements, we need to terminate, like we need to use this semicolon as the delimiter to indicate that this is the statement ends there. Now as a first step in the database, or like to work with the database, we wanted to create a database or a schema. Then we'll create tables in it. So but the first step is we need to have the schema. Only then we can have the tables under it, as a schema is a like used for grouping up of tables. So I am creating a database now. This is the syntax for it. Create database testdb. And this need not be in lowercase or uppercase. It can be, it is not case sensitive. Remember so MySQL is like whenever we are writing the commands, it is not case sensitive. It can be lowercase even, create database, all things. But here, just to identify that's a keyword from the keyword for the MySQL. So I am just representing it with the uppercase letters. So let me execute this now. This command, first command. So what you need to do here is you need to select this entire command like this, or you can, as this is the only statement, you can just do Control A as well, and then you can see some icon here. Now I'm going to execute this command. Select the whole command like this, and then click on this icon. So you can see some icon here. You can click on this icon which executes the command, and you can see here the output of it. So it says create database testdb is the action in the output, and message is one row affected is what it said. And on the left hand side we find schemas. We don't find our schema, right? So just click on this refresh icon. You can see a refresh icon on the right side. So click on that. Now you will see testdb being created here. So we created a scheme database successfully. You can see it here. If we expand it, we don't see any tables in it, as we didn't create any table yet. We just created a database under it. This is how we can create a database. And if we don't wanted that database to be existed on the MySQL database, you just can use the drop command. So we can use drop command, drop database and the database name. So this is how we can drop it in the sense deleting or removing it from the list of the schemas here. So let me run this. You can see it here. This is the syntax of it. I selected it and just click on this icon, which actually executes that command. And you can see the output here. Drop the database, message 0 rows affected. We should always see a green tick mark here, which means that the actual query is executed successfully. And you can see testdb is not listed here as we dropped it. Dropping database is removing the database. And you can see the same thing can also be done using schema, like as both database and schema are same in MySQL. So you can see it here. We don't have the schema testdb now, and we created it using database keyword. Now we are going to create the same using schema. Create schema, my schema name. To execute this command, just click on this icon. You can see the message here. If you have this in green color tick mark on the leftmost uh, column here, which means that the query executed successfully without any issues. If there are any issues, we'll be seeing a message here related to that issue. We'll get some error here. We can check that error message and correct that error. Now if you can see it here, just refresh in this schemas. You will see a refresh icon here. Just click on this. You can see it here. TestDB has been listed here in the schemas. In the same way, like if we actually use drop schema name, then that will be dropped or removed from this list of schemas. See, I selected that and will use this icon to execute this command, and you can see that is dropped. The schema testdb is dropped. This is how we can create a database and drop the database using database keyword or schema keyword. Now we have another way of creating the database. We will see that now. You can see it here. Create database if not exists database name, which means that create a database only if it doesn't exist. So what does that mean is, if there is any database or schema name with testdb, so in that case don't overwrite it is what you are saying. We'll see that. See, let's create database testdb using the command, and we can see it here. We have testdb. If we actually execute this, you will get a warning here saying that we already have testdb. So it says one warning, can't create database. TestDB database exists already. And this time this was not successful and it's a warning. And the warning is indicated with a yellow triangle with an exclamatory mark inside it. This is the use of it. Uh, Say for example, we don't have this database. I'm dropping this database. Now we don't have it. Now let's execute this. Let's see what happens. So in this case, create database if not exists. It is not there. So it is actually, it created the database. You can see the success messages here. This is another way of creating a schema or database. And just click on this refresh icon, you will see the schema here, testdb. This is how we can create a database or schema in MySQL. Next, we will see how to create a table. How to create a table? How to create a table? You can see here, like we are done with creating the schema or database now. Now we wanted to create a table. So this is the syntax of the table. So without creating a table, we can't actually see the data, right? So only once we are done with creating the schema now. The next step is creating the table. Then we'll actually add some data into the table. And you can see this is the syntax of the table. So we need to use again like create command table. We are saying that we wanted to create a table. This is optional. If not exists is an option. So whatever is option, the syntax will be represented in square braces. Create table. If not exists, table name, actual table name. This can be anything, and we should be opening a brace, and then say the column definition. We should be providing the columns. Whatever columns we wanted to have to as part of this table, we need to mention it here. Like and comma another column, comma third column. Like this, we can have n number of columns defined for the table. This is the syntax of creating a table. Now let us see one example. You can see it here. First thing is we need to use the command called use testdb. So why we need to use this is we will be telling database that MySQL that I have one DB, testdb. So once we connect to the database, you can create a table, fine. But we have many schemas here in MySQL. Where you want me to create this table? So MySQL database will have that ambiguity, right? So for that, we need to use this statement. We first execute this command called use testdb, and this will be persisted for the whole session. So what does that mean is I wanted to perform some transactions now, or I wanted to execute some SQL commands, and all these should actually should be performed under my schema called testdb is what this command means. So first of all, we need to use this command. Use, the command itself is use schema name, and execute it using this icon. Or the shortcut is control enter. So keyboard shortcut is control enter. You can select this whole command and do control enter, or you can click on this icon. See, we said use testdb, and you can see the result. So it is successful. Now MySQL knows that whatever queries we are from now onwards, whatever queries we are going to run, all that will be uh, ran under the testdb. So whatever we perform will go into the testdb schema. Next, we wanted to create a table. Let's create a table. Let me take this syntax from here. You can see here, I wanted to create a table. So the syntax is create table. This is the syntax, create table, and you can see here book. So book is my table name. And then you can see the list of columns here. So create table, table name, open the brace, and and within the braces we need to define our columns. So how to define the columns? First, column name. My first column name is bid to represent book id, and then column data type. So what is a data type is each column or each piece of information we will have some data stored, and the data can be of any type. Say for example, if it is a salary, it will be a number, or if it is an employee ID, then it will be integer. Integer in the sense it's a number. So to represent a number, we need to use the data type as int, or if it is a string or like a sequence of characters or a text like names. You wanted to store some names, titles. All these comes under names or text, right? So in that case, we use a data type called varchar. These are the representations in the database. So we usually call them as strings, text, like that. But the terminology in database is this one. So the equivalent of that is varchar here. So that is what we need to say to the MySQL, that I am defining one column book ID, and that ID will have the data of numbers. It will only have numbers, is what we are saying to the MySQL database. And this is how we need to actually write the syntax for a column. So you can see here, BID is my column name. It will always store the numbers, and numbers are indicated with int. You can see here int, comma. I have uh, other columns as well. So the second column name is B title. So book title, and it will have the text. So the data type of it is text. So what's the data it will store? That column, it will always store text. It will not store any numbers. So it will store text is what we wanted to say. And in varchar, you can also store numbers. So numbers will also be part of text. Say for example, if you wanted to store something like test, so you can see test or also test123. If you wanted to store that, that will also be accepted if you have the data type as varchar. And the size here. So what's the size of your data? We need to specify that. The maximum size we need to specify here. So here, as I am creating the table book, so I wanted to have first column as book ID, and book ID is always number. So I represented the data type as int. Then book title. I know book title will always be the alphabets. So I created as the data type as varchar, and it should not exceed 100 characters. That's why I gave the maximum size as 100. Then the author of the book. So author of the book is like author name. So that will also be varchar, and a name of a person. What I think is like it should not be exceeding 30. So I give the maximum size as 30. So and then quantity. Quantity is another column. Uh, Quantity, and quantity will also be a number. So I wanted to declare it as an integer data type. So like this, we can define like any number of columns with their data types. We need to know what the data will be for that column, what type of data that column holds. That data we need to represent it here along with the column name when we are defining a table, when we are creating a table. Then once we are done like specifying the column names within the table, then we will close this brace. And as each statement in MySQL will end with semicolon, so you can have the semicolon here, select the whole command here and execute it. See, I am executing it now. And this table should go into my test DB. As we already executed this use test DB, so MySQL knows that whatever operations we are performing now onwards will always goes under this test DB schema. So let me execute this now. Now you can see the output here. So it is successful. It says 0 rows affected. And how to confirm that it is created? So you can just go to here on the tables, right click, refresh all, and expand these tables. So you can see a table here under tables book. So we have a table created now with the name book. You can expand this, and it has columns, indexes, foreign keys, triggers. So for now we'll look into columns. So just expand columns, and you can see all the columns whichever we created just now for the book table: BID, book ID, book title, author, quantity, all this. And in the below of this window you can see the information of it. So whenever I click on column, it says the column name is BID, and it is of integer type is what it is saying. This is how we can create a table using create table command. Now we'll discuss how to insert data into a table. So what is inserting data into a table is, we now have the table created. You can see the table now with this structure: BID, B title, author, quantity. These are the four columns, and the table name is book is fine now. Now how to insert the table? How to insert the data into the table? So the syntax for that is insert into table name. You can see it here. Insert into is the command we'll be using. Okay, insert into which table, that we need to specify here. Insert into some table, values, then in the braces we need to specify the values for that table. What is the data we wanted to insert? Inserting is adding data into the table. This is the syntax, and you can see the example. So again, like we don't need to use testdb again, as we are already in that session. So we are already pointing to testdb schema, so we don't need to use it again. Now we wanted to execute this insert into statements. You can see it here. These are all the different, we'll see it one by one. So you can see it here. We wanted to add some data into this book table, and how do we do that is using the command called insert into. So you can see here, insert into is the command, and uh, you can see you clearly differentiate what's the keyword for the database and what's the value, customized value, whatever we provide, that is represented in black font, and what are all the keywords are represented in blue, in font blue color. You can see it here. So insert into book, so table name, values, then in the braces we need to provide the data. And how do we provide the data is, we know that the first column is book id, so we need to provide some number here, as the data type of bid is integer. So I provided some data here which is a number. Then observe now, the book title is of text data type or a string. String in the sense it's a sequence of characters or alphabets that we need to always specify in single quotes. You can specify the text, but that has to be in single quotes, as we are just to represent that is a varchar data type or a text value. You can see I provided some book title here in single quotes. Then author, the third column, we wanted to provide data to the third column, and the third column, what it has author, and it is also defined as a data type varchar. So we need to again provide some text into this column, and you can see each column, after each column we are actually providing comma here, just to represent that column data is completed there. And you can see the third column data here is, I provided some text here, the author name, and as that is varchar, I am providing that in single quotes. Next, fourth column data. So fourth column data type is integer, that is number. So I need to provide some number, and number we don't need to provide in single quotes. So you can directly provide the number. Only if it is varchar, that is, if it is of text data type, we provide that in single quotes, just to represent and inform MySQL database that it is a text. This is how, this is the entire command to insert or add one row into a table. And what's the prerequisite for this? You already need to have a table in the schema. So we already have the table created under testdb. We have the table now. The table name is book, and we don't have data in the table, and we wanted to add some data into the table. That's the reason we are writing this syntax. You can see here, insert into book values, then the actual values to be inserted into the table. So select the whole command here and click on this icon, which means that execute. And you can see here the output, one row affected. It says one row affected, and it is successful. The transaction is successful. Now how to identify that it is successful or not. Like we wanted to see the data in the table, right? So for that, for now, what we'll do here is just right click on the table name and click on this select rows. It will actually issue some select command to the database and it will fetch the what are all the rows present in that table. Click on that. So you can see here. You can, for now you don't need to understand this, but just observe the data here. This is the data we have in the table. This is the table we have with 4 columns, and you can see the data. We just now inserted this data into the table. You can clearly see the data. This is how we can confirm that whatever row we inserted just now into the table has been added to the table successfully. Now let's go back to the our editor. Now we will see other way of adding data into the table. So this is another way. Insert into table name book. Here we can specify the order of the columns as well. So you first in the first type we need to provide the data in the order of column creation. So first column was book ID, second was book title, author, quantity. So in the same order we need to provide the data. But now I don't wanted to follow that order. So in that case, what we can do here is insert into book is the table name. Then we can specify the column names here. That need not be in the same order which we gave while creating the table. You can see here while creating the table, the first column was book ID, but I specified here as author, then book title, then came the book ID quantity. So you can see the order is not the same that of while we created the table. It's a different order. Then we need to specify values, and in the braces we need to specify the data according to the order which we provided here. You can see here insert into my table name. I gave some column names here which are all existed in the table itself, but not necessarily in that order. I provided in my column names in a different order. Values, again we need to use the values keyword here, and then provide the data in the order whichever we specified here. So I specified author here, so I give author name first. Then book title, give book title here. Then came book ID. So give book ID as is it's a number, didn't provide it in single quotes. Then came the quantity. Quantity is again a number. So provided some number here. So this is another way of adding data into a table. So insert into table name, columns. Columns we can specify in any order, values, and the actual data in the order whichever we specified the columns here. So select this whole command and execute this using clicking on this icon. You can see here it again says one row affected. So again to know this, like what we need to do here is whether it is added to the table or not, we can just right click on this, do select. Now you can see it here. The second row also got inserted into the table book. So this is how we can confirm that the second row also got inserted successfully into the table book. Now in the same way, like I wanted to add one more row into the table, so I am just adding it here. But if you observe, I am not sure on the quantity of this book. There's a book with this name written by this author, but I'm not sure the quantity of sale of this book. So we can in that case, if we don't know something, we can just provide it as null value. So we'll discuss on this null later in the same session. So for now, if you don't know the value, you can just pass it as null. And this is the syntax of the first way how we inserted into the table. So the remaining data for the other columns is provided, but we are not sure of the quantity, so providing it as null. So whenever you are not sure of what the value is, so you don't need to provide it forcefully some dummy value. You can just provide it as null. And let me execute this. So it is successful. You can see it here, a green tick mark. Now we'll go back, we'll execute this command just to check whether that row is inserted into the table. Yes, you can see it here. The third row is also got inserted into this table. So now what we have a table book with 4 columns and we have 3 rows in it. So we learned how to create a database, how to create a table inside it, and how to insert data into that table. Now we will see how to select rows from a table. So what is selecting? This comes under DML, DQL, data query language, data or DRL, data retrieval language. So using select command, we can actually read or retrieve rows for some columns, some specific columns, or all the columns from the table. So for that, the command is select list. Select list is where we specify some column names here, which are present in that table. From what's the table you wanted to get read the data from, that we need to specify here. Select command, then select list is column list, some whatever columns you wanted to view as we are reading the data. So we need to provide what are all the columns we wanted to read and view from the database, that we'll provide here. And then the syntax is from, we need to specify the table name, from which table you wanted to select the column list, that we need to provide it here. So example you can see here. So we'll actually modify the schema to this classic models, and we'll see all these examples now. So if you observe, I am using classic models here. So TestDB has only one table that we created now. But if you observe, this classic models has like 7 or 8 tables here, you can see here. And how to get this classic model schema is, I am going to share you some script here, so that you are going to execute it. So how you execute it, let me show you. So once you execute that script, you will also get this classic models schema in your database, and you'll also see this tables created. So how to actually create that script is, I'll be sharing you the script, and how you need to execute that script I'm going to show you now. So just click on this open file, open SQL script, and this is the script. You just need to give this final script, double click on that, and this is the script. You just need to select this script, or you can do just Control A, so that entire thing will be selected, and you just need to click on this execute. So I'm not doing this as I already created this classic model. So in your case, if you just do this, so you will get this schema, classic model schema in your database. I'm just closing it for now. Once you have that classic model schema, like how I have it here, you will also have it once you run that whole script. Then what we are going to do, we wanted to work work on some tables inside a schema called classic model. So for that, the first step is, we need to tell MySQL that we are going to perform some operations on a schema called classic models. So how do you specify that? Using use command, use classic models. First execute this. See, this got executed successfully. Fine. Now we'll go to this classic model schema, and here are the list of tables inside it. So it has customers table, employees table, offices, order details, orders, payments, product lines, products. All these are the tables under this schema, and each table has some columns and some rows in it. So we'll actually see each table information according to our requirement. Now you can see, first of all, we'll as part of select command, we wanted to understand what select command is, right? So select command reads or retrieves the rows from a table. This we know. And how to do that, how to issue that command, we'll see it now. Select star from employees. So it has employees table. You can see it here, and case doesn't matter here. So even though you see it in lowercase employees table name, you can provide it in either lowercase or uppercase. So the objects are not so it doesn't matter. Case is not mattered here. So I just provided in the uppercase letter. So now this is the syntax to read all the rows. So star indicates get me all the columns which are all in the employees table, and select indicates get all the rows. So select indicates to read the rows, and after select you see some star, so which indicates get all rows. Star means for all the columns from table employees is what we are saying with this command. Let me execute this now. And now you can see the data here. So it has employees table has employee number, last name, first name. It has extension, email, office code, who the this particular employee reports to. Reports to is like the employee ID of the person who this particular employee reports to, and the job title. This is designation. So these are all the different columns we have in this employees table. And you can see these are the columns, and you can see the data for each row. So there are like number of rows here. You can see once we execute it in the output, you can see the message here 23 rows written. So meaning this table has 23 rows. So you can slowly scroll down here to view all the data from this table. So this is about like reading all the rows from employees table and for all the columns. Next syntax is about select. I don't wanted to read all the columns from this table. I just wanted my first name, last name, and job title of the employee. This is the information I wanted to view or read from the database. So in that case, the syntax is select column, the column list. You can specify it, each column separated by a comma, and then from which table you wanted to read the data. Just execute this now. Now you can see we are not getting all the columns here. Select indicates rows, and you can see all the rows here. You can see the 23 rows written, fine. But coming to columns, we only see 3 columns here. Whatever we wanted to read here, we specified as part of the select list, and we specified the table. And from this table, all these 3 columns will be displayed, and the data will be returned for all the rows present in the table. You can clearly see it here now. This is how we can read particular columns from a table using the select command. Now see this, select employee number, and if you see here, let me run this select star from employees again. And even this is also not case sensitive. This column name employee number is in some case, and we can specify it in uppercase as well. So case doesn't matter here. Case only matters in the data. So that will cover in a few minutes. So for the data, case matters. Table data is case sensitive, but not the actual objects. Structure of the objects, case doesn't matter. Case we can call it as case insensitive. So employee number, last name, all this we can provide in any case. It need not be the same case which we gave it while creation. It can be in any case. So that's the reason you can see it here. Employee number, I gave it in uppercase, but what this means is EMP ID. This we call it as alias for the column. Alias is another name for a column, and this will not be persisted anywhere on the database. This is just for our information. When we execute this, this is how the column name will be displayed in place of this uh, large or big column name. Instead of this, you don't wanted to see this entire employee number column name, but you wanted to replace that with some value, some alias. That alias you can specify it beside the column name. So first name, I don't want it to see it the entire first name. I wanted to just view it as F name here in the list. So we can specify that alias here. And job title, I just wanted to view it as designation. So I gave some designation here from same table name. So let me execute this and show you. If we execute like this, so you can see here the column names, it is actually employee number. So the column name was employee number, but We are just providing it as some alias, and that is what we can view it here. It was first name, but we wanted to just for, and this is only restricted for this query itself. It is not persisted on the database. Remember that. So we are not modifying the column name here. So as we can't modify it using select statement. So using select statement, we can only read the data from the database. And this is about, we have some actual name in the table, the column name, but when I'm selecting the data for reading, I don't wanted to see this name as the column name. I wanted to replace it with something else. That's the reason we are providing some alias here to that particular column name, that we can clearly see it here. And first name, I just wanted to view it as F name, and job title, I just wanted to view it as designation. So that's the alias we have given here. And when we execute it, so instead of actual column names, the aliases whichever is specified in the query will be displayed here. And this is about only columns, but row data is same, like rows, the 23 rows will be the same, 23 rows will be written here. You can see it here. There is no change in the table actual data. And we have another syntax like where you can actually uh, add or perform some operations on the data which you view. Like say for example, we have some employee IDs here, right? So I what if I add some number to each employee ID? How does that looks like? I'm not going to modify data on the actual database, but if modified, how that how it looks like? I wanted to verify that. So in that case, we can just verify it like this. Select employee number. What happens if I add plus 1000 to each number? So put me that information with column name as employee ID, EMP ID. Then this is routine, like you have first name, but put me display that column name as F name. So I know there is a column called job title from employees table, but when you are reading, don't display me as job title, display that as designation is what we are saying it here. And for the employee number, we are just adding some number here, as that is EMP employee number is, you can see it here. I'll just expand this employees table. In the columns, we can see it here. When I click this employee number, it is integer. It is integer. It is defined as integer. So I can add some number to it. Just for my information, how if I add some number to it, how the information looks like is what we wanted to check. So that also we can represent it like this. So let me execute this statement now. And you can see earlier it was all starting with 1, all in thousands or 1100, 1200, but all turned into 2000s now, as we added 1000 to each employee number. And this is not actually persisted on the database, just remember that. So this is just for our information. What happens, like if I add some number to it, how the data looks like is what we wanted to verify. That is what we can do it here using the select statement. And this is how we can use the select statement to read the data from the table. Now we'll see what are all the different SQL data types we have. So data type is used to actually specify MySQL database, that any database in that case. So we wanted to specify the database that I have a column. I'm going to create a table. In that I have some columns, and each column can store any type of data. Like one column might store numbers, one column might store text, some columns might store date. But which column stores what? We need to specify while creating the table itself. When we are specifying the column names. So the what's the type of data my column is going to store is called as a data type. And there are like 3 data types in SQL. So you can see it here, 3 data types: numeric data type, string data type, and date and time data type. So numeric data type, if you specify numeric, so if under numeric again we will have different types. So we'll see that now. but all those are categorized into numeric data types. Under string again we'll have many other data types, and date and time will have other different data types. So but here we will use all numeric data types to store numbers according to our requirement. String will use it to store text, that is sequence of characters, and date and time will store it to store some date information in the columns. We'll see all of this like one by one. First we'll see numeric data types. You can see it here. Numeric data types are like, if you wanted to store, if you already know that if your column will not store like big values, it will only store some small values which fall under the range of some 255, from 0 to 255, you can just declare your column as tiny int. Int represents integer. So tiny int is what the column data type you can specify. If the data range is very less, like if it is only if it holds, if we wanted to have the data between 0 and 255, and if it is like around some thousands, like 5-digit number, then you can go ahead with small int. So you can just specify your column name as small int. Likewise, if it is like more than 5 digits, if it goes like 7 digit, then you can specify it as medium int. Your column data type will just specify it as medium int. So these are all the different ranges. Like if it is still long, if it's huge value, then you will just specify it as integer. Then the value you provided to your column can be like any number, any number between this range. It can be even negative number. So negative number starting from this number, -21474 something to this number. It can fall in any range between these. And big int is still long, like it is huge number. So you can store if it is like a, big number, then you can actually declare your you will know that while defining the column, what would be the data you'll be storing in that column. So according to the requirement, we should be choosing one of these data types. So if it is numeric data type, so we should be knowing that what can be the possible values for your column. So according to that, according to our requirement, we'll choose one of these data types listed here. And float is decimal value. So you'll also have like decimal values to be stored, like item price, like that. So in such cases, like we will be using salaries, commission, all this will be in floats. So you'll not only have it in direct integers, but you'll also have decimal points. So in that case, we can use float, and float is used to only store only small decimal point numbers. And if you have it as a double, then a large number floating point decimal point can be stored. So then the precision can go long. Like say for example, if you wanted to store something like 123 dot some 5 6 7 8 9 like that. So in that if you wanted more scale, then you can actually specify it as double. Decimal is also decimal is also a double stored, but it is stored as a string. So mostly decimal or double is used for currency values. So these are the different numeric data types we have, and we should be declaring these data types for our columns according to our particular, like according to the specified requirement whenever we are defining the column. Then comes the string data types. So string data types are used to store the string data or text or the sequence of characters. And you can see it here. If it has like only, if it is gonna store your string is has only 255 characters, it will not exceed more than 255 characters. In that case, you can just declare it as char. Or if it is so long that it might go till some 65535 characters, then we can actually declare your column as varchar, and you can specify that the length, the maximum length of your string in the braces. So varchar of, just now we saw in our example while creating the book table, we declared two columns as varchar, and we provided according to our requirement one number. That number is maximum number, like a maximum number of characters that column can actually have the data as the value into it. That we specify in the varchar. Then blob and medium blob, long blob, all these are used to used to store the images, videos, mp3 files, media files, all for these on the database. Not only the data, so there will be requirement to store like images, mp3 files, video files, like that. So all these will also be converted into some binary objects and will be stored into the database. And for that we need to store it as, or we need to declare such columns as blobs. And text is also like you can see text. So in some cases we need to save like number of characters. It can even go into description or paragraph, or if you wanted to store some web page information itself. In that cases we can have it as medium text or long text, so that you can see the maximum length of characters here. So it's in millions of characters, right? So in that cases, you can declare your column data type as text. That is medium text or long text. Again, that depends on the on our requirement. Next comes date and type, data type. So we in some cases we wanted to store like a column. Say for example, you wanted to store some customer information or some employee information. You wanted to store the date of birth. So in that case, we will actually declare some column in the table, and we'll actually have the data type of that column as date. Maybe date. If you specify date, so then you can just specify this date like this. And the date format is, you can see it here, YYY. So year first, then month, date. So in this order, we can specify the date. Likewise, we have another data type called date time. So in some cases, we wanted to store some column where we wanted to actually store the date along with the date. We wanted to also store the time. So that in this format, like year, month, date, then particular hour, minute, represents minute here, ss is seconds. In the so mostly we use some columns for event logging. In that cases we can use date time, so that at that particular point of time that event has occurred. If you wanted to store such type of information, we can actually have some columns declared as date time data type. And timestamp is also like same as date time, so we can represent it in the the whole year and as combined with the time. Then if we have time, then we can just actually have a column specified with time as well, where we can have hour, minute, and particular seconds. So these are all the data types. So this is how the data will be into the columns. And there is another data type called year. In some cases, we don't need entire month, date, and all. We just wanted to store year for some columns. In that case, you can just declare your column data type as year. These are all the different data types we have. So according to our requirement, we need to actually create the columns and specify that data type. Now we'll see what where class is. So where class is used for selecting the rows based on some condition. So till now what did we learn? When we wanted to read some data from the database, we can actually use select command, and beside the select, if we specify star, we will get all the columns. All the columns will be read from the database. Anyway, rows we will get all the rows. And if we specify select and then a particular column list, then only that number of columns will be read from the database from that particular table which we specify here, from the table name, which whatever we specify here. So that will be retrieved here. This is what we learned. And when we wanted to restrict the columns, we can specify it beside this select command. How about rows? So how to restrict the rows? So that we didn't learn. That we can do it using the where class. So select some select list, that is my column list, from my table, some table name. I don't want to read all the rows from the table. So the table can have some hundreds of rows. but I'm not interested to actually view all the rows from the table, but where search condition. So we in that case we wanted to filter the rows based on some condition. The condition can be anything. So that we are going to see now, where some condition here. Based on this condition, only particular number of rows will be filtered and that particular number of rows will be displayed on the client. Only that particular number of rows will be read from the database and will be displayed on the output. So this is the use of where class. Now we will see different examples of using where class. So you can see here, first thing I wanted to do is use classic models. I wanted to use tables from this schema. So for that, we just need to execute this use classic models is the schema which I wanted to work on. Like I wanted to execute some queries, like whichever these are the tables. I wanted to read it from this classic model schema. So first I will execute this. I already executed this. Now let us execute this. So select star from table gives us all the rows from that table, and as we are indicating with star, all the columns will be read from that table. So let me execute this now. Now you can see these are all the different columns in employees table and these are the different rows. So we can see it here. How many rows got written in the message? 23 rows written. These are the different rows in employees table. And you can see the column names also here. Column names, these are the different rows when we specify it as select star from employees. Fine. Till now we know. Now I am not interested to display or list down all the rows here, but I just wanted to have the employees whose designation or whose job title is sales representative. You can see it here, sales rep. So I wanted to view the information of employees whose job title is sales rep or sales representative. So in that case, how do we retrieve the rows or employee information whose job title is sales representative? In that case, we'll specify it as select star from employees. Fine. I wanted to retrieve all the columns which are all present in the employees table, but I wanted to restrict the number of rows to the employees who has the job title as sales rep. Then in that case, we need to use where class. So you can see the syntax here, where job title equal to, so job title is the column name equal to the actual value. What's the value? Sales rep. And this has to be as is. Data is case sensitive. Remember it. Remember this. So data is always case sensitive. So if I specify yes small case here, then no rows will be written here, as the actual data is indicated with the uppercase yes, say in the sales. So it has to be exact. So we need to have the same data here specified, and as this is again text, we need to specify it in single quotes. Whenever we are using the text in SQL, then we'll be specifying always with the single quote. Just remember that. And this is the syntax of it. So with this query, we can actually read the employees, all the employees information whose job title is sales representative. With this condition, we are going to filter the rows now. So just remember, there are total number of rows is 23. So now let me execute this command. Now you can see there are only 17 rows written, like out of 23. So there are like 17 employees whose job title is sales rep, and this is the information of them. And you can clearly see here what are the rows written here. The job title of them is sales rep, as that is what we wanted to read from the database. So this is how we can specify some condition using where class to filter out the number of rows. So in the same way, like if you observe, let me execute this select star from employees again. Here I wanted to, there are like number of office codes if you see here. So each employee has one office code to which in which office that employee works in. I am interested to actually view the employees who works in some particular office code. So in office code 6, who are all the employees working, that I wanted to view. So in that case, we can specify the condition as select star from table employees where my office code equal to 6. This is the condition. Retrieve all the rows, but filter the rows with office code equal to 6. So the rows from which like office code equal to 6, only that rows I am interested to view. So in that case, we can write the condition like this, where class condition like this, and execute this query. Now you can see there are only 4 rows written here. You can see it here, and the data also you can in the data also you can see it here. So we have the employee information, but we got employees who actually works in the office 6, office code with 6 as the number filtered out. Like this, we can actually perform some arithmetic operators on the condition. Like say for example, I wanted to execute, let us actually execute select star from customers. So there is another table customers. Let me show you that, or let us execute it. So you can see it here. Customers is one of the tables in classic models schema. Let us execute this customers table now. And this is the customers table, and you can see there are like number of columns here: customer number, customer name, last name, first name, phone number, address line 1 to city, state, postal code, the country to which the customer belongs, sales rep employee number, and credit limit. So these are all the different columns for a customers table, and it has like many rows again. You can see it here. How many number of rows? It has 122 rows written. So it has total 122 rows in total, and this is the customer table data. Now we are not interested to view all this all the information of the customers, but we wanted to read or look into the data of the customers whose credit limit is greater than 200k. So this is what we wanted to view. So in that case, what we can do here is we can just write the condition here. So select star from customers, but I wanted to filter it on the credit limit. Credit limit is one of the columns. So credit limit greater than some number. You can I just give some number here. So greater than 200k. So let me execute this. And you can see here there are like 122 rows. Out of that, there are only 2 customers who have the credit limit greater than 200k. And this is the information of those customers. This is how we can filter the rows, and we can use like other conditions as well. Say for example, for the same query, I wanted the customers whose credit limit is less than or equal to is also we can use. So this is how we specify that condition. So this specifies greater than, and this operator specifies less than or equal to. Credit limit less than or equal to 30k is what I wanted to look for. I am looking for that. So just execute that query. So you can see it here. So these are the customers whose credit limit, you can see here, credit limit is less than or equal to 30k. We can also verify all of this data even. So all of this data will either be equal to 30,000 or will be less than 30k. Likewise, we have something called is null. So what is null? So if you see here, some rows have null information as null. So null is neither null is neither blank, it is not empty, it is not empty spaces, it is not zero. What null is? Null is not blank, it is not empty, it is not it doesn't mean it has some empty spaces, it is not 0 even. Then what it is? So null represents missing value. So if there is null, which means that it is a missing value. It doesn't, that particular column doesn't have any value, is what we mean by null. Now we wanted the information of customers who doesn't have, like whose state was missing, whose state was not provided as part of the information of that customer. So in that case, we should be specifying a keyword called is null. So that the information which is missing for the customer for the state column, then that rows will be filtered out. So let me execute this, you'll understand. So you can see here there are like 73 rows, like 73 customers for whom the information of state was not provided or missing. So that missing information will be indicated with null. And just remember, this is not, null is not equal to empty. So I can actually have some empty string as well. So how do we specify empty string is single quote, open single quote, and if I say some a and close it, so we can see it as we have some data that is a, but I can even remove this. I will not have anything, but I will just open the single quote and close the single quote. So even this is valid, but this we call it as empty string. So an empty string is a string of length 0, but this is not equal to null. Remember that. And even I can have some space here. Just open some single quote, some space, and then close the single quote. Though you will not be able to see any data here, it will be empty here, but still that is not equal to null. And in some cases you might see some 0 for numbers. That is not null. Okay, so just remember this is very important. Null, but then what is null is, null represents missing value. If you do not provide anything to that column, then that will be treated as null. And in your case, like there are like 73 customers for whom the state value was missing or not provided, that we can actually filter out using the keyword called is null. You can see it here, is null. And you should not be giving it like this. So state equal to null, like how we gave it here, office code equal to 6, credit limit equal to 30K. Like that, you should not be specifying state equal to null. This becomes invalid. So you can also check this. So in this case, you will not get any rows here. You can see it here, 0 rows written. So it should always be represented with is null keyword to filter out the rows with the missing information. And now let us understand distinct. So let me execute this command. Select office code from employees. So I wanted to look for the employees information. Let us first execute employees information. So this is the data which we have in the employees table. Fine. Now I just wanted to look into office code. So I'm interested to actually read only office code column. So for that, select office code column from my table name. Let me execute this. Now I can see office code here. As I am interested only to read the column office code from employees table. So this is how I provide the syntax. And you can see the data here. But if you observe, there are like 1, 1, 1, 2, 2, 3, 3 like this. But I don't wanted these duplicates to be displayed here. I'm just interested in like how many office codes are there. Unique office codes are there in the employees table. I am interested to look in that. So for that we can use a keyword called distinct. I wanted the office code from employees, but it should not be like duplicated. Why we have this duplicate is there can be more than one employee working in the same office. So for that we have this duplicates. But I don't wanted these duplicates to be displayed here. I wanted only unique values of the office codes so that I can actually get the count, or I can actually see the what are all the office codes. So for that, what we can do is we can actually specify the keyword called distinct, which actually eliminates the duplicates and displays only the unique office codes. So this is the syntax for it. Select distinct office codes from my table employees. Execute this command. Now you can see we don't have the duplicates and we have only the unique values. And to retrieve the unique values, we need to use the keyword called distinct. You can see it here. So in the same way, like if you have some duplicates, say for example, if you have some information in one row and you actually insert the same row again and again, 3-4 times. So that we call it as duplicates. The same information, if it is repeated more than once, that we call it as duplicates. And say for example, in like select star from employees, we don't have such information, but you can see here there are 23 rows, right? So if some information is repeated, some row is repeated, and we don't wanted to actually see the duplicate information. We wanted to see only unique information for all the rows. Then in that case, here we used office code, right? But now our requirement is to have the eliminate the duplicates from all the columns. So in that case, we just need to specify with star. Select distinct star from employees. Execute this. So you can see it here. So in our case, we didn't have any duplicates, but just think of like we had some 3 rows which we already had. So in that case, if we do not specify distinct, we'll be getting 26 rows. And as 3 rows are duplicates, when we specify distinct star from employees, we'll get the 23 rows. This is the use of distinct keyword. So remember, distinct keyword is used to retrieve unique rows. To read unique rows. This is all about where class. So where class is used to filter the rows based on some condition. Now we will see some operators which we can actually perform on the on using where condition. So these are called as logical operators. We have and, or, and not. So I am going to execute some queries which are under classic model. So I'll execute first this use my schema classic models, and I wanted to look into information for employees table. This is the employees table. It has 23 rows. Fine. Now I wanted to use a keyword called and. So there can be uh, a condition like here. If you observe, we used where class. Fine, but we used only on one column. We can actually use where we can specify where class, and there can be more than one condition specified. So how to do that? We'll see it now. So you can see it here. Select star from employees where my office code is 1 and job title also should be sales rep. So the requirement is like I wanted to retrieve the employees whose designation is sales representative and who actually works in office code as well, office code 1 as well. So if we only specify this job title as sales rep, we also have that query here. Let me execute this. Then you will get 17 rows. Like across this entire table, we have like 17 employees who are working as sales rep. But now we wanted to read the number of employees whose office code, who works in the office code 1, and they should be sales representative. So who are all the sales representatives working in office code 1 is what we wanted. So in that case, we need to specify a keyword called and we can specify more than one condition here. So with this, we can achieve like office code 1. So it has to satisfy office code 1 and job title also should be sales representative. So let me execute this. So we don't have okay rows. And you can see why there are no records is sales. Let me execute this select star from employees. I'll show you the data. You can see the data here is sales rep, sales space some empty space rep, but I gave it as sales underscore rep. That's the reason the condition failed. So if the condition is failed, then we will not get any results. Just now we saw, right? So here also, like if you specify some office code as some 60 600 like this, then you will not get the results, as as there are no rows with this with matching with office code this number. You can see 0 rows written. If this condition is failed, then no rows will be written. So just remember that. And here also, as we give data as incorrect, so no rows were written. Now we'll execute this. We corrected the data here. So job title is sales space rep rep, and who is actually working in office code 1. Let me execute this. And you can see here we got like two results, two rows. There are two employees who are actually working as sales representative in office code 1. Both has to be satisfied. As both conditions has to be satisfied, we will be using AND condition. Then we can use OR operator between any two conditions. And what does this return is, either this can be true or this can be true. Any of the condition is true, then uh, rows will be retrieved. But when AND is used, both conditions should be satisfied. So the employee should have the title sales rep, and the employee should actually work in office code 1 also. Both has to be satisfied when you use AND operator. Only then such type of row will be retrieved. You can see here these are the only two rows like that. So uh, the employee who is whose title is sales rep and who is working in office code work, both has to be satisfied when we specify AND operator. And when we specified OR operator, either of these conditions can be true. So I wanted to read employees who either work in office code 1, or if the job title is sales representative also, I wanted to read the data. So in that case, we can use the operator or logical operator or. So let me execute this. And in this case, you can see there are like 21 rows. There are like 21 employees whose job title is either sales rep or they belong to office code 1. We don't know. The employee can belong to office 1, or if the employee title is sales rep. So the the combination of it will be read here. So either of this condition is true, then that row will be picked up. So you can see it here in the data itself. So if you see the first row, the job title is not sales rep, but still that row is retrieved as it has office code 1. Even the second row has VP sales as the job title. It's not equal to sales rep, but office code is 1. That's the reason it was retrieved. And you can see some sales rep here, and whose actual office code is not 1, but as his job title has the employee job title is sales rep, so that row was also retrieved. So the point to be noted here is, when we use logical OR operator, even either of the conditions is true, one of the conditions is true here, so the data will be read. This is about logical OR operator. And what is not? Not is just opposite to equals. So we can specify something like, say for example, I can say where last name equal to Murphy. So I wanted to read all the employees whose last name is Murphy. Let's do that. You can see I have one such row, one such employee whose last name is Murphy. And you can see here, it also says one row written. Fine. Now, it is just, when I use not, it is just reverse of it. So I wanted to retrieve employees whose last name is not Murphy. So just reverse of it. So I wanted to read employees, all the employees from the employees table, but their last name should not be Murphy, is what we wanted to execute. So in that case, we can specify not keyword here. So just select this and execute the query, and you can see there are 22 rows. As we know, the total number of rows in employee table is 23, and one row or one employee has the last name as Murphy. So only leaving that row, we got all the rows here. So this is just the reverse of equals. So if we wanted to eliminate something, then using like not equals, then we can use the not given. These are all the different logical operators we have. Next, we'll see between and in operators. So what is between and in operators? We'll see that now. So in some cases, we wanted to actually filter the rows based on some range of values. Some range of values like, say for example, we have, let's execute customers. You can see customer table data here. And each customer has some credit limit. So there is one column credit limit for in the customers table where the credit limit for each customer is specified here. And we wanted to actually read the customer information who has the credit limit between 50K to 100K. This is the so whenever we wanted to specify some range, then we can use this between keyword between some starting value and some end value. So if we wanted to actually filter some condition based on some range, then we can use this between keyword. So if we execute it, so it has actually 122 rows, but there are like 60 customers whose credit limit is between 50K and 100K. So when we wanted to read the data based on some range of values, then we can use the between keyword. So I can just put it here. No, not between. So just not between is reverse of it. Just now we saw not, right? In the same way, not between also works. So you can see it here. Like not between is exact opposite of between. So I wanted to retrieve customers, all customers whose credit limit is not between 50 and 100K, 50K and 100K. So we should be getting the credit limit less than 50K and greater than 100K. So in simple, what we can say here is like we had 122 rows and between 50K and 100K, we had 60 rows, right? Now we should be getting 62. And you can see here, we got 62 as this is just the reverse of the above one. So if we wanted to don't want the information between some range of values, then we can actually specify not between. Next we will see in operator. Say for example, I wanted to have like customers information whose credit limit is like it can be 11K, some 21K or some other number. So these particular numbers, if the credit limit is equal to particular numbers, I wanted to read that type of customers information is what my requirement is. In that case, we can actually specify like using OR condition, we can specify it. Just now we learned what logical OR does. So either of the case is true, then that rows will be picked up. So exactly now our requirement is that. So either it can be some value 11K or it can be 21K or it can be some value like this. We have some list of values. So in that case, how we can write the condition, you can see it here. It can be this number 21K 846 00 like this. We wanted to write the condition. So we can specify number of OR conditions like this. So either of this value matches, then that row will be picked up. This is how we can do it. Let me execute it. So you can see it here. When we execute this where condition, so either credit limit is this number 84600 11K, anything, that row will be filtered and be displayed. But say for example, if I wanted to perform some 10 numbers like this, then your query looks very big, right? You just need to repeat this credit limit equal to and this or condition like many times. But instead of that, how we can achieve the same is we can use the in operator. So you can use the in operator and specify the values whichever you wanted to search for in the braces. So if the values, the credit limit matches any of these values, then that row will be retrieved. That's the use of in operator. You can see it here. Let me execute it. So the same number of rows will be read and will be displayed here. So if you wanted to match with a group of values, or like if you wanted to match with some particular number of some specific number of values, then we can specify that specific values in braces, each value separated by a comma. You can see it here. So this is just a replacement of this. You can have number of or conditions, but the query looks big if you have more values. So in that case, you can just match those values using the keyword in. So in the same way, like we also have not in. Not in is just the reverse of it. So give me return me all the rows which for whose the credit limit is not belongs to these values. So we have 3 rows written. Now let me execute it. So we have 122 rows in total. You can see it here, like there are like 119 rows whose limit is not equal to either of these values. So if it is equals, we got 3 rows. If it is not equals, so this is the data of the customers whose credit limit is doesn't fall under these values, will not match these values. You can view the data as well. So you will not find the data with these values here. That's the use of not in. So it's just the reverse of in. In actually gives us the results which matches these values, and not in gives us the values except the matching values listed here. That's the use of not in. And pattern matching operators. So we have pattern matching operators. So what does that mean is, so we'll see that now. In some situations we wanted to write some condition where like we are not sure like what the data looks like, but we know that uh, there is some first name which actually uh, is coming from my employees table. So there is some employees table. Let me execute this. So I have employees table and I have first name as one of the columns, and I wanted to retrieve all the employee information whose first name starts with L, whose first name starts with L. So in that case, how to actually filter out the rows. So in that case, we'll write the where class first name like we need to use the operator called like here, the keyword called like, and then in single quotes we should be specifying L, and this is case sensitive. Data is always case sensitive. So data is what we specify in the single quotes, and that is case sensitive. Remember, L is the uppercase letter. Then we are representing it using the percentile. So percentile is called the wildcard character, which actually matches multiple characters. Meaning, what's the meaning of this is, I wanted to retrieve employee information whose first name like is how it is like or equal to, whose first name is equal to. Now we are specifying the condition. How it should be first name. It should start with L followed by multiple characters that we are representing it using the percentile symbol. It should start with L and it can have any number of or whatever number of characters, whatever character it can be or whatever number of characters it can be. But it should always start with L is what we are representing here using percentile and like operator. So let me execute this now. So you can see it here. This is the actual employee information where we have 23 rows, and you can clearly see the first names here, different first names. Now let me execute this, and you can see we get the employee information whose first name starts with L, capital L, uppercase letter L. You can see here Leslie. Leslie, we had like two employees with the same first name, and some Louis, Larry, like this. And it can have any number of characters. But what we are interested is, we are interested to display the employees whose first name starts with L, uppercase L. And it can have any number of characters that we represented with percentile. And how did we write the condition? Where first name like is what we need to use this wildcard characters. Now in the same way, we will see some more examples. Like if you see here, the second one, I wanted first name employees whose first name looks like, so it can have anything, like starting thing can be anything, but the name should end with Y. So in that case, this is how we can write the wildcard character matching. So first name like percentile represents any number of characters, multiple characters, but the last character of the name should end with lowercase y. So let me execute this now. Before that, let me execute all the employees first. You can see this is the data of all the employees, 23 rows, and let me execute this now. So we got the employees like 5 rows written here, and you can see each employee first name ends with Y here. These are all the employees whose first name ends with Y. And to actually read that, we need to specify the while character percentile, which actually represents the first name can start with anything, and it can have any number of characters, but it should always end with Y. So for that, this is the query. And we can use, you can see the another example, like the name first name should start with uppercase A, and in between it can have anything, but it should end with Y, same as the above one. But out of this, it should have, the name should start with A, the first name should start with uppercase A is what we wanted to look for. So for that, we should be getting these 2 rows. You can clearly see it here. Let me execute this, and you can see those are the rows we got it. So the first name starts with A, and it can have any number of characters after A, but always the name should end with Y. So in that case, we can use the query, we can write the query like this. Next, we wanted to have just S as the character in the first name. So small case letter S should be present in the first name, and before that it can have any multiple characters, any number of characters, and after that character lowercase s, it can have any number of characters, multiple characters. Percentile represents multiple characters, and it can be 0 or more characters. Remember that percentile represents 0 or more characters. It may or may not be present, the characters, and it can be any character, and it can have multiple characters as well. So this represents like we wanted to search for first names whose first name has letter S in it, lowercase s in it. So let me execute this, and it has like 4 rows written. So these are the letters. So first names which has S in them, letter S in them. You can clearly see here. Now you can see here, not like. Not like is just the reverse of like. So the name should start with, the first name should start with M, but it should not have any characters. Let us first try with like. So it should start with M, and it can have multiple characters followed by it. And if you execute it, so these are the rows written. Like there are 3 rows whose first name starts with M, and it can have any number of characters after it represented using percentile. But we don't want that. Exactly, we don't want that. Like we are just wanted to write the exact opposite query of that. So we wanted all the employees, but we should not be having the first names starting with M. Then we just need to specify not like. Now you can see in the first name you will be seeing all the first names here, employees first names here, but you will not be seeing employees whose name starts with M here. And you can also see there are only 20 rows written. Then this is important. Another wildcard character is underscore. So what does underscore represent is, it represents a single character. So let me put it here. Wildcard character representing multiple characters. Multiple characters, 0 or more. And underscore is used to represent single character. Now we'll see how to use the single character. Like you can see it here. So we wanted to have first names which has like some, it can start with something, it should have small case r in it, and after that it should end with a single character. So we can simply call it as last but one letter is should be r, is what this means. So in order to filter it out like that, we can use a while character underscore. So percentile just represents one or 0 or more characters. So there can be some characters in the first name, but it should have a character R, and once the small case letter R is seen, then the following letter should be only single character, and that character can be anything. So it is almost like in a name, the last but one character should be R, is what we can represent using this underscore. Just remember, underscore represents single character. And you can see there are multiple results here, like there are 5 rows. And in each name, if you observe, the last but one letter is R. So it started with something representing percentile, and it has R in it. And after R, it can be anything. Like it can be anything, but it has to be only single character. You can clearly see it here. After R, we have Y. After R, D, here Y, like that. So that is how we can represent using underscore, which matches single character. And say for example, I wanted to have like first names whose first names are only 3 characters. So I am interested to display first names from employee table whose length of first name is 3 characters. So in that case, what we can do, we can just have it in single quotes, 3 underscores here. You can see it here. These are 3 underscores representing, each underscore representing one character. So I have 3 underscores here. You can see it here. These are 3 underscores, meaning there can be there has to be exactly 3 characters in my first name. So first name having length 3. Let me execute this, and you can see there is only one such name whose first name is having length of 3 characters, as we represented using underscore, each underscore representing one single character. Say for example, let's add one more underscore here and let us execute it again. Now we have some 5 rows written, like whose first name has length 4. This is how we can use the wildcard characters. Percentile representing matching multiple characters, and underscore matching single character.